In this video, you will learn more about planning the migration and various steps involved in it. There are different tools provided by SAP for various purposes to help with the migration. They are ABAP Test Cockpit, Code Inspector, SQL Monitor, SQL Performance Tuning Worklist, and ABAP Trace in Eclipse. You can see the details about these tools in further slides. ABAP Test Cockpit. This is a new tool given by SAP to check static ABAP source code. There are many features for this tool. It helps to analyze ABAP source code developments. Critical source code can be evaluated in terms of performance, security, globalization, quality in general, and check variants. This is based on Code Inspector but with additional features. To use the tool, you have to open the program or package in T-Code SCAT. Click right button on it, select Check and choose ABAP Test Cockpit. Once executed, it will display the results like given in the screen. ATC can be opened through Eclipse as well. Here, open the program and select the option from the menu Run. The results of the same will be given like shown in the screen. You can configure the tool before using it. The T-code for the same is ATC. It will look like shown in the screen. The various options in the tool include overall administration, setting up periodic executions, add exceptions if any, finally options for quality governance. Code Inspector. This is the tool which can be database independent but has specific checks for HANA. Transaction code is SEII or SEI. This is a static tool and hence no runtime measurement data is provided. Code optimization can be done using check variants. Custom variants can also be created. It can be used to check the code in terms of quality standards, robust programming, and security. Functional variants in Code Inspector. There are three functional variants given by SAP within Code Inspector check variants for HANA migration. First one is functional DB, which contains checks that are regarded as mandatory for the analysis of ABAP custom code as part of an SAP HANA migration. These checks primarily relate to areas of robust programming, security checks, and search functions. Second variant is functional DB addition, which points to functional errors and statements with low performance. These are not mandatory, however recommended. Third variant is performance DB. This is for performance optimization on SQL statements. Refer the OSS note mentioned in the screen for more details on these variants. More details on the functional variant, functional DB. This is the mandatory code inspector check variant for HANA migration. There are certain problematic program lines which may lead to functional variances if not fixed. So this variant helps to discover them. Though priority 1 and 2 findings are highly concentrated, priority 3 level notification are also checked. There are check classes for the 5 main check cluster. So it is important that the system has all the up-to-date objects. Here you can see some situations where it was fine working before and causes issues with HANA. Usage of explicit sorting. This is the background. As you all know by now, HANA database makes use of column store technology. The implicit key field sorting of the classical databases cannot be relied anymore. Without correction, the functional output of the objects will be corrupted. So what is recommended? Avoid robust programming by using implicit sorting of internal tables. Correct the same using explicit sorting by either including an order by clause in the select statement or by using sort by statement in the resulting internal table. Here is an example of the explicit sorting. In the source code given, in read statement, binary search is used. So as its prerequisite, order by clause is added to the select query with the primary key values. Here you can see some details on why it is recommended to avoid using pool or cluster table in HANA database. Here is the background. It is not advisable to access the physical pool or cluster directly. The logical table is transformed to a transparent table after depooling or declustering, which may lead to absolute errors when accessed. The reference of the physical pool or cluster continues to exist, but with empty content. So what is recommended? Remove all the reference of physical pool or cluster table in all select, update, modify, delete statements. Replace them with the logical reference of transparent tables. Also, you can check in the various list to see the full list of tables using this physical table, pool or cluster. Here is an example of using cluster table. In the select query, the table KOCLU is a cluster table used. And as the correction, it is updated to use transparent table KONV. There is a table of messages given by code inspector shown in the screen for all the select, modify, update or delete statements. Now we can again see some background of using native SQL and also what is recommended when on HANA database. Here is the background. Native SQL statements for any database might become problematic after migration to HANA database. For example, statements like exec, end execute, db hints. Now what is recommended? The best solution would be to migrate the code to OpenSQL. If it is not possible, then adapt native SQL and database hints if necessary. That is, remove or adjust Oracle specific syntax to be able to perform on HANA database. Please refer to the SAP official portal for more details on the supported SQL dialect of SAP HANA. Database shared library hints for SAP HANA can be viewed in the note given in the screen. Here is an example of native SQL. In the source code, exec and end execute is used. These statements define an area in an ABAP program in which one or more native SQLs can be specified statically. The area between exec and end execute is not checked completely by the syntax check. The statements entered there are passed to the native SQL interface and processed there. So as recommended, this has to be converted to OpenSQL like shown in the screen. Now you can see some background on usage of where condition within SQL statement and what is recommended when on HANA database. Here is the background. Select, update or delete database records without where statement are usually not a sign of robust program in any database. So what is the recommended way of doing it? Check the functional logic, especially on statements update or delete and the select statements on big or application tables. and apply where condition wherever possible. If the functional design requires select, update or delete on the entire table, then the message can be hidden with the pragma given in the screen. Here you can see some details on using for all entries. The supplement clause for all entries in the SQL query hit multiple tables, and also it does not make sure that the internal table is not empty. So what is recommended? Use join statement wherever possible. In the code inspector, try to avoid false positive findings. Still, it is possible that the table was already checked at some other place in the flow. In case of false positives, it is still suggested to do a correction to help the scanner. On long term, this will help to easily detect the erroneous use cases and avoid performance issues. Here you can see some background check on table inconsistencies. Table buffering in HANA database still has important performance advantage, but most of the secondary indexes are not needed anymore. So what is recommended? Double check the buffering and other technical settings for those tables. Some of the example cases are buffering is activated but delivery class is A. Here, buffering application table can cost a lot of memory space. Another example, buffering is initial but data class is APPL2. Here, frequently used customizing table can be buffered. One another case where table has more than 7 secondary indexes. Here, most of the secondary indexes are obsolete in HANA database, so you can review and remove wherever possible. Understanding performance consideration using the functional variant Performance DB. Performance DB is a recommended check variant for running static performance check run for ABAP custom code. It contains all the required static SQL performance checks. The processing of static performance check results is not effective in an isolated view. ABAP source code in pure static checks are not critical in terms of performance and may not be used at runtime. SQL Monitor transaction code SQLM is an important utility to identify performance optimization capabilities. It collects statistical information about all SQL statements initiating from ABAP program. Using the runtime monitoring setup in the ABAP kernel, SQL Monitor can run in a production environment and in parallel to the live usage, thereby collecting the optimized runtime data for the executed SQL statements. This runtime data collected often provides immediate work list, which includes potential performance improvement points for custom code, and they can be merged with the resulted data of the static performance checks. This linking of both data sources is performed in the SQL performance tuning worklist tool. Results from other static performance check tools can also be linked with the results of SQL Monitor that give suggestions on solutions. The SQL Performance Tuning Worklist, transaction code SWLT, is a tool which combines the result set of source code analysis with corresponding live data available in a production system. This data consolidation helps produce prioritized worklist to optimize SQL performance. In the screen, you can see how the SWLT tool results look like. Now you can see here the snapshot of features and the tools which supports them. The main features are divided into three. First one is static code check. It identifies location of non-critical code constructs. For example, select star. The tool which is supporting it is ABAP Test Cockpit or Code Inspector. Another feature is runtime information from production system. This collects performance of Key figures of code constructs. Tool supported is SQL Monitor. Another feature is combined work list. Combines the static and runtime check results, provides a more comprehensive view, and the tool which is supporting this is SQL Performance Tuning Worklist. ABAP trace using Eclipse. Here you can see how to trace ABAP object using Eclipse tool. First create the trace under project and provide the name. Then using the menu option window, select show view and choose other, which will open a pop-up, and then select ABAP traces from the list, which will display the results like shown in the screen. In the trace results overview, you can see different sections like general information where it mentions about the trace name, who has created and all. In runtime distribution, it will give the overall percentage distribution in different areas like ABAP database, system, etc., which is quite similar to the old SE30 in SAP. And in the last tab, it elaborates all details like hit list, database accesses, and so on. Here comes the end of part 2 video. Please go through further videos to understand more about migration topic. If you get an opportunity, start incorporating the learnings. All the best.